Jai Hind. Basic differentiation rule. So here we are discussing some basic rule. First is constants rule. In constant rules, we use differentiation of any constant number is 0. So this d upon dx is called differentiation sign, and any constant, suppose we are taking c as constant, so its differentiation is 0. Another example, suppose we are taking 2 crore. 2 crore means 70, so its differentiation is 0. Any constant number, its differentiation always 0. Sometimes we see the question x raised to power 0. So any number who has power 0, its value is 1. It means it is a constant and its value is 0. Its value is 0, not 1. So this we have to remember. So this is first rule. Now second rule is power rule. Second rule is power rule. In power rule, if so here is y equal to x raised to power n. Differentiation of y equal to x power n. Its differentiation is we get n x raised to power n minus 1. This is called power rule. So power rule, it means the power of x was n, that comes in front of, so we get n, then x power n minus 1, power will decrease by 1, and we here have solution by first principle, this rule. So power rule says differentiation of x raised to power n is always n, power comes in front of, and x power decrease by 1. So n x power n minus 1 is the answer. Take some example. Suppose question is asking x power 100's differentiation. So 100 will come in front of, and then power will decrease by 1. So power will be 99 of x. So 100 x power 99 is the answer. Suppose take one more example, x power 1 by 2. So 1 by 2 comes in front, and 1 by 2 minus 1. So my 1 by 2 minus 1, it means minus 1 by 2 will left. So minus 1 by 2, power will always be write in positive term, positive sign. So we send it into denominator. So it is written as 1 upon 2 x power 1 by 2, or it is further written as 2 under root 2 under root x. Under root x means power 1 by 2. So x power 1 by 2 means under root x. Under root x differentiation is 1 upon 2 under root x. Or we can prove it by this way, or we can know this is called power rule. So any number, remember it, the power, any power, if suppose minus 1 is there, it's the differentiation we want. So we write minus 1 in front, then minus 1, then minus 1. We decrease one more power, so it gives us minus 1 upon x power 2. Because minus 1 it becomes minus 2, and it power become positive when we shift from numerator to denominator. So this is second rule, power rule. Third is, so next is, third one is sum rule. In sum rule, sum means addition. So here we take two functions. Suppose fx is first and fy is second, and their sum is there. So differentiation of this function, we can write d upon dx, and differentiation of first fx, then we write plus, then differentiation of second function, we will get the answer. This is some function. Suppose take an example, d upon dx, suppose 3x square plus a power x. We want to differentiation. So what we do, we first differentiate 3x square, then write plus, and then differentiate a power x. So 3 is constant multiple of x square, so 3 come in front of d by dx. X, only x square's differentiation we need. And similarly we know the differentiation of a power x. What is the formula of it that we have to use here? So 3 written as it is, x square differentiation is 2 into x power 1. So according to power rule, and a power x differentiation is a power x log a. So this is the answer. So what we have learned from here, there are two terms. Both the terms are differentiated separately, and that is our final answer. So 2 3 is 6x plus a power x log a is the answer. Suppose question is asking differentiate e power x plus 3 power x. So its differentiation, we here separate out, either there is plus sign or minus sign. For both we use same. If there is plus, then we use plus. If there is minus, then we use minus. Then differentiation of 3 power x. So e power x differentiation is very easy. It is same as e power x, and if there is plus or minus, we write same sign. And 3 power x, its differentiation is like a power x. A here is 3, so a power x differentiation is a power x log a, and 3 power x differentiation is 3 power x log 3, because we replace here a with 3. So this is the answer. Next rule is difference rule and sum rule we have studied here. So it is also included in difference rule. Both are same, both we have discussed. So plus sign is there, then we use plus. If minus is there, then we use minus. Next is product rule. It is important sometimes. In product rule, suppose two functions are given, fx and fy. These are two functions given equal to y, and we want to find the differentiation. So how we differentiate it? So in this case, dy by dx, differentiation of these. So here is two function. What we do? We do not differentiate first function first time. We differentiate only second function first time. So it means differentiation of second function. Then we use plus sign, and now we do not differentiate second function. This time we differentiate first function. So alternatively, we use one function differentiation at a time and separated by plus sign. Take an example. Suppose y equal to e power x into x square is given. How we differentiate? So if we want to differentiate, we use product rule, because there are two functions multiply. So first function written as it is, e power x written as it is, and we differentiate x square. Then what sign we write? Plus sign. Now second function we write as it is. Second function is x square. We write as it is, and differentiation of first function, that means e power x. So e power x written as it is. X square's differentiation, we know that it is 2x, and here x square written as it is. E power x differentiation is e power x, and e power x taken common. So and x also taken common. X e power x taken common. So inside we get 2. Inside we get only 2 plus x. This is the answer. Or we can also say above step, previous step is also our answer. So in product rule, first we can consider one function. We can choose any one. Either this can be considered first or this can be considered first. One function we write as it is, other function differentiation, then plus sign, then other function constant, and other function differentiation. So it means this is called product rule. So two function are there. One function, this is the formula. One function consider as constant, because when we consider it constant, it comes out of the differentiation sign, and other is variable. So others variables we differentiate. Similarly, at second time, we consider second as constant and first as variable. So and separated by plus sign. So this is the product rule. Next is quotient rule. Quotient rule. What we do in quotient rule? In quotient rule, the function are given in numerator and denominator form. Suppose two functions are given and its differentiation we want to find out. So how we differentiate? Let us take an example, d upon dx, and function here we consider is suppose a power x upon x cube. So two functions, one is numerator, another is denominator. Two functions are there. So how we differentiate? We write square of denominator. So denominator is x cube. We write square. Then now after squaring, we write as it is denominator. So x cube written denominator same as it is. Then differentiation of numerator. We write d upon dx of a power x. Then put minus sign. Remember it, we put minus sign. Now numerator written as it is and differentiation of denominator we write. So this is the quotient rule. Now we further simplify it. X cube, a power x differentiation is a power x log a minus a power x, and x cube differentiation is 3x square upon x power 6. Power will multiply when bracket sign is there. So this is the answer. We further can take common or simplify step we can take. So x square is common. So inside is left x, a power x log a minus a power 3 into a power x upon x power 6. So 6 among 6 power, this 2 power go in denominator and becomes minus 2. So 6 minus 2, it means x power 4 will left in denominator, and numerator we can take also common a power x. So inside we left x log a minus 3 as final answer. So this is the answer. I hope you have understood. So in denominator and numerator type function, there we use quotient rule. So in quotient rule we write again, listen, denominator is square and then denominator written as it is in numerator, then numerator's differentiation, then put minus, then numerator written as it is, then denominator's differentiation. So this is whole completely is called quotient rule. Next rule is chain rule, and this one is the backbone of this differentiation. Chain rule. Chain rule. So in chain rule, remember it, function inside function is there. Function inside function will be present. Remember it. And its differentiation we want to find out. So how we solve? First we differentiate of this f dash means differentiation, and f dash g of x differentiate, and second time we differentiate this g of x. So there is multiply. So take an example. E power 3x plus 2. Taking this example. So first function, f of function is e power x. So e power x differentiation is same as it is e power x. So this is same. Now we see there is not x, there is some variable. So differentiate again this variable. So it's a differentiation 3x plus 2. So 3x differentiation is 3. 3x differentiation is 3 because x power 0 means 1. So 3x differentiation is 3 and plus 2 differentiation is 0. So only answer of this is 3 e power 3x plus 2. So this is the answer. So what here we see? We here see this first consider as x. This first consider as x. So e power x differentiation we write as it is. Now we differentiate it, this term. So its differentiation is 3, that we write here. This is called chain rule. So again take an example. So here is 2 by mistake. because we copy as it is. Now take chain rules example. We are considering here an example d upon dx of log x square. So log x square. So what we consider? First we consider this as x. So log x differentiation is 1 upon x. So x means this whole term, log x square. This whole term we write as is x. 1 upon x is the differentiation of log x. Now what we do? Now we differentiate this term, d upon dx log x square. Now differentiation of, again now this time we consider this as x. So again log x differentiation is 1 upon x. So we write here again this term is 1 upon x. So log 1 upon log x square into 1 upon x square. Then we see here is not x, here is x square. Now this time we differentiate this x square and its differentiation is 2x. X square's differentiation is 2x. How? We write 2 in front of x and 1 power of x decrease. So 2 power is there. So 2 minus 1 is 1. So 2x is x square's differentiation. And other terms are written as it is. So this is the answer. 1x from numerator and denominator cancel out. So final we get after simplifying 2 upon x log x square. This is the answer. So I hope you have understood. These are the basic differentiation rule that we consider in the chapter in the beginning of differentiation. Okay.